All right, so this is an example similar to problem 2.5.15 on your homework. And in this problem, they are asking you where is the function continuous. So they'll give you a function. In our case, let's look at the function x plus 1 divided by x squared minus 3x plus 2. And they're asking where is this function continuous, and give your answer in interval notation. So where is f of x continuous? In other words, we have to find where it's not continuous and then pick everything else, right? All right, so let's figure out where this isn't continuous. Well, first off, we can notice that x plus 1 in the numerator, that's continuous everywhere, right? That's just a linear line, so that'll be continuous everywhere, so we don't really have to worry about that. And then we got to look at the denominator. That's also a polynomial, so that's going to be continuous. Just the denominator itself is going to be continuous everywhere. But when we're dividing by it, we have to remember we cannot divide by 0, right? Like that's the biggest, sort of the biggest no-no in mathematics, right? Can't divide by 0. So I'm going to write can't be x plus 1 over 0, right? Okay, so the question is, when is this thing equal to x plus 1 over 0? Well, it's whenever the denominator is equal to 0. So let's look at the denominator. Well, that's x squared minus 3x plus 2. Let's set that equal to 0, and let's solve for when this is equal to 0. So you'll notice this is a quadratic, so we could either use the quadratic equation or we could factor this. It's easy enough that we should be able to factor it, so let's look at this. So it should be x minus 2 times x minus 1, right? Which we can then solve as x is equal to 1 or 2. All right, so these are the points where it's discontinuous, right? So it's discontinuous at 1 and at 2. All right, so that means it's continuous everywhere else. All right, so I start all the way to the left at minus infinity, and I go until I hit my first value where it's discontinuous, which is at 1. So I'm going to write negative infinity to 1. And then union, this is the set notation that shows up in my intro to naive set theory video. It's a union. And then 1 to 2, right? I keep moving to the right until I hit my next discontinuity, and then union again, 2 to positive infinity. All right, so that is the set of x values where this function is continuous. That was a horrible square, but you get the point.